prove that n to the power of 2 is not big omega of n to the power of 3. So we know that n to the power of 2 is not big omega of n to the power of 3, because if we write it in our inequality, we have n squared is greater than or equal to c times n to the power of 3. Intuitively, you know that this is not true, because this is basically saying that a quadratic function grows faster than our cubic function. And that is not the case. It is actually the other way around. We're going to use proof by contradiction. So suppose that n to the power of 2 is big omega of n to the power of 3. So if n squared is big omega of n to the power of 3, then this means, according to our formula, that there exists a positive constant c and a positive integer n naught, such that n to the power of 2 is greater than or equal to c times n to the power of 3, or n is greater than or equal to n naught. And what we're going to do is divide both sides with n to the power of 3. So we have n to the power of 2 divided by n to the power of 3, and that's greater than or equal to c times n to the power of 3 divided by n to the power of 3. But this is the same as multiplying by 1, so we can remove this here. Now, one thing to note is when we divide both sides by n to the power of 3, the sign stays the same. We don't flip the sign because n is positive, right? We're basically saying n is greater than or equal to n naught, and because n naught is a positive integer, then n will always be positive. But that's why when you divide by a positive variable, the sign stays the same. Also, n to the power of 2 divided by n to the power of 3 is the same as 1 over n. At this point, some of you may realize that this here is not true, right? Let's draw out the graph and see what this means. So if we draw out the graph where the horizontal axis is n, c is a positive constant. So let's draw c. C is a positive constant, so it will be like this. And let's draw 1 over n. So 1 over n will look something like this. And notice that, let's say we pick, so let's say here is our n naught. So starting from n naught and going to the right, we can see that 1 over n, our function 1 over n, is always below our red function c. So in reality, this is true. But over here, it says the exact opposite, which means that this is our contradiction. We're going to write this is a contradiction since the limit as n approaches infinity of 1 over n is 0. Basically, we're just saying that this function is approaching 0, or it's approaching the horizontal axis as n approaches infinity. And the limit as n approaches infinity of c, right? So this is the line of c. So as n approaches infinity, it would just continue to be c. It's not going to change. Because of that, 1 over n is less than or equal to c, for n is greater than or equal to n naught. So this is the way to say it, and therefore, n squared is not omega of n to the power of 3.